So first we'll start actually my teammate Bugra, if he will be able to introduce us.
Hello everyone. I'm Bugra and this is my colleagues Firangiz and Dzhavidan. Firangiz and I both work as a data scientist at Capital Bank as a AI and data science team. And our presenter today, Dzhavidan, is the data scientist at Digital Research Lab. Firstly, I just need to be small talk about Capital Bank. Is a primarily serves retail customers with about 4 million active clients in Azerbaijan, and we are presenting our work on improving our call center's voice assistant system today. Previously, voice production was manual and often taking a month, and finding voice artists and studios was time-consuming and challenging process. Now we can producing accurate and natural sounding speech, and this enhance customer experience and efficiency. And now I will hand over the Javidan for the paper details. Thank you.
Okay, next slide, please. One more. One more. Okay, so in our case, we want to design a text-to-speech model in Azerbaijani language. The problem is the last open source model was designed in 2014 and the quality is really bad and it's really felt that it's done by machines. And the other possibility for us was to use Microsoft's text-to-speech model, but that one was again too robotic. And in our case, we needed something that's natural. So we had three choices: Tacotron 2, Beats, and Fast Speech. And our choice was at the last point Tacotron 2 because it's known for its natural noise. But the problem in our case was that we only had 45 minutes of audio data, which was studio quality and was currently in use in our call center. So next slide. So what we had to do was to simply increase the amount of data. I'm not going to delve too much into Tacotron 2 system because we haven't made huge changes. The only thing I can say is that we used PyTorch's Tacotron 2 implementation that's open source on GitHub. And also for vocoder part, we used HiFiGAN because as it's general adversarial network architecture, there is not huge need to fine tune it. And in our case, time was a valuable resource. Next slide. So our overall methodology was to use transcription model to get more data. We will scrap open source audio data that's high quality. Then we will transcribe it. We will perform different data techniques to clean it as much as possible for Tacotron 2. Then we will pre-train Tacotron 2 on this transcribed data. And as the last step, we will fine-tune this pre-trained model with our studio quality data, which will allow us to use transfer learning despite having little data. Next slide. So the model we used is that something that has already been discussed many times. It's Whisper, specifically large version 3. The problem for Azerbaijani language is that it's at 39th place out of 57 languages, and it currently has 24% word error rate, which means it makes a lot of mistakes. And in our case, that was the case as well. And on the left side below, you can see the decoding parameters we have chosen. The only thing I can recommend that's out of ordinary for others will be to use voice activity detection, specifically Sleva version 3.1, which is currently available on GitHub, and it's enterprise grade voice activity detection filter, and it helps Whisper to make less mistakes and also to trim silences audio might have, because as you may know, text-to-speech systems are really sensitive to bad data, especially Tacotron 2, which uses location-sensitive attention. So if it has a lot of silences, that will also be produced in our production. Next slide. So in this way, we got 24 hours of audiobook, which was a single speaker female audio. The quality was quite high, but after we get the output from Whisper, we saw that a lot of outputs were kind of bad for text-to-speech. Specifically, for instance, there were cases when only 0.5 seconds of audio was given, which is only one word, or the opposite, where it was 30 seconds because the sentence itself was huge. So we had to do a lot of data cleaning. Specifically, the most I would say were done what you can see on the screen, which is removing audios that are less than 2 seconds and more than 12. Also removing audios where more than 0.5 seconds of silence existed. For this purpose, we use whispers, segment start and segment end parameters, which is inherently available in Whisper model itself, and it worked quite well. And also VAD filter for cleaning the data that is like full of silences. In our case, we got audio length with our Gaussian distribution. What I mean is our overall audio length wasn't skewed in any way. For instance, we didn't have a lot of short sentences or long sentences, and average audio length was around 6 seconds. So this gave us, after all the cleaning, about 11 hours of data, which we use for pre-training. Next slide. And here you can see the results. I will say we tried two different models. One was only 46 minutes audio itself, and one was with 11 hours, then 46. If you could hear one of these examples, which is of our final audio,
Bankda yeni hesap açmaq istəyirəm.
you can see it's robotic, but the good thing about it, which was needed, was it makes little to no hallucinations because it already knows most of vocabulary. For instance, another example, if possible.
Kreditlə bağlı məlumat əldə etmək üçün bir düyməsini seçin.
So the way, as you may know, PTS models are evaluated is by mean opinion score, which is basically having a lot of subjects that are ideally native speakers and related to your topic that will evaluate your model on different metrics, and then you would average it. In our case, we use the same with 10 independent speakers from call center, which are seen in the next slide. The above model is only 46 minutes audio of studio quality, and the below is audiobook plus studio. What this shows us is that there is possibility even for languages that perform badly on Whisper's benchmark, let's say, to actually get some value from transfer learning with a lot of data. What we are trying to do right now is to increase that amount of data with more good quality open source data, to transcribe it, to clean it, so that we could see the difference if increasing it even further would actually assist us in improving our TTS audio quality. Currently, our model has a MOS score of 4.11 and is already used in our call center. Like if you called bank's call center, you will hear the voice. And at the last slide, I wanted to give some recommendations if someone wants to do something similar, because the overall pipeline is actually not that hard, I will say. The only thing I would recommend that helped us improve quality even further is when you're fine-tuning on higher quality data, to improve dropout value from 0.1 to 0.4, and it helped us avoid overfitting because the majority of data that the model has seen was from audiobook, which is another speaker, another quality, and so on. And also there was an intermediate try we did with 11 hours of audiobook directly taken from Whisper, and also 11 books of audio manually corrected. And we have seen that it helps the model make less hallucinations, but in general, there wasn't like huge difference. So maybe if someone wanted to do something similar, they could simply take a lot of data and transcribe it without needing to manually correct, because that takes a lot of resources and time. And lastly, segmentation by Whisper actually works quite well, and it's not hard to do at all. That was all from me. If you have any questions, please go on.